fraction division. Hopefully those videos, for those who have joined us here now, were good. Just as an introduction, I'll kind of start by reviewing that. The fraction division algorithm. So now this is actually kind of a tricky thing. And in the book, I think they talk about it being a culmination of elementary mathematics. And my explanation of this is, I'm still working on it, so we'll see how it goes. Okay. So our question is, how do we build an understanding of y a over b divided by c over d is equal to a over b times b over c, okay? Which is the fraction division algorithm. You multiply the reciprocal is what they call it. Yeah. So the first step is to build an understanding of 1 divided by a unit fraction. Why is that equal to the denominator of the unit fraction? So I like to show a number example because the variables are a bit abstract. And so we've done this before, 1 divided by a third, which means how many groups of 1/3 fit into one whole? So what kind of division is this? Measurement or partitive?
Isn't it partitive?
Why do you say that?
Because you're taking groups and putting them into a whole.
There you go. Okay, it's actually measurement because I'm going to take off groups of 1/3. I'm going to do 1/3 into one whole, then the next third into a whole, then the next third. I'm taking my whole and subtracting off groups of 1/3 if you think about it that way too. So that was a good guess though. You can think about this as partitive, but it's a little bit trickier. Maybe you were thinking about it partitive and I was thinking about it measurement. Because if you have how many 1/3 can fit into one whole group. Anyway, I think about it measurement, it's a little bit easier. So we have, I'm going to draw 1/3 here as a reference. And so here's 1/3. And then you see how many of those fit into my whole here. So I'm going to divide up my whole into thirds. Okay, so I use long dashes, or these long divisions for my group size. I know there's one that can go in here, one that can go in here, and one that can go in here. 1, 2, 3. And so 3 groups of 1/3 fit into 1. And then with the letters, D groups. Oops. Of 1/D fit into 1. And that will always be the case. It goes from the definition of 1/D. The unit fraction definition means one part where D copies of it make the whole, right? So it's like the very essence of the unit fraction definition. Part number 2. Then they went to 1 divided by C/D. When we put a non-unit fraction, that's going to be D/C. It'll be the reciprocal of C/D. So for example, 1 divided by 2/3. This was the same as my first example, but in this one, it's going to be a non-unit fraction, and I have 2/3 there. And so we have to think what that means. It means how many groups of 2/3 fit into the whole. So that's what that means. We're going to draw a picture of that. So I draw a picture of 2/3. Okay. And here's my third. The bottom bar again is going to be reference. So that's 2/3 right here. And separate my bar into thirds as well. This is going to be a big dashed line for the end of my group. So I have one group of 2/3 that fit into there. And my second group of 2/3 is a little bit further past this bar. There's my second group. But I'm not going to use the whole group. Okay. So then I need to ask this question. I'm going to use a dashed line here. That's where it would be if it was that long, it'd be 2 whole groups, but it's not. It's only part of it. So here's my thought. How much of a group of 2/3 is this 1/3? Okay, so I've taken 2/3 from one group, and I just have 1/3 left of my whole bar. We need to think about how much of a group of 2/3 that is. Does anybody have an idea? This is my 2/3 right here, and I need this much right here.
Isn't it 1/2 of the group of 2/3?
Right, it's 1/2 of the group of 2/3. Okay, because I have a 2/3 I just tacked on there, and but I'm not using all of it for the rest of the whole. I'm only using half of it. So we have one whole group plus a half of another group, okay, of 2/3. Let's change 1/2 to our improper fraction, 3/2, because that will give us some more insight about how this works. Okay. So 1/2 groups, or 3/2 groups of 2/3 fit into 1. So we've discovered that. So I'm using 3/2 here. And 3/2 is related to my initial division problem. It's actually D over C. So there's D over C groups of 2/3 or C over D fit into one. Okay, we can already see the reciprocal coming in, and it happens to work like that all the time, no matter what groups are. You always take the denominator and make it a new numerator. Actually, maybe the numerator becomes a denominator because I'm looking at that as the new whole. Okay, so look at this part right here. That becomes the new whole. When we're thinking about how many groups of 2/3 come out. Okay? So that's why it goes into the denominator here. And you'll always have the old denominator number of parts. Okay? Number of pieces. Okay? Let's keep building. We have a whole number divided by C over D. That's going to be equal to, we're going to show that that's equal to the whole number multiplied by the D over C. Okay. So for example, instead of 1 divided by 2/3, we have 4 divided by 2/3. Okay. What's it? It means how many groups of 2/3 fit into 4. Okay. So I'm going to take off groups of 2/3 from 4. So I have to draw 4 units here. 1, 2, 3, 4. A little bit short. Yeah, so how many groups of 2/3? Here's my reference bar. There we go. Okay, so big line will be at the end of the group here. So we have 1 there. Move this one over a little bit. Then this one right here. Another group of 2/3. And this one right here. The third one. Fifth one. And the sixth one way out there. Okay, so there are 6 groups of 2/3 that fit into 4. Six is also equal to 4 times 3/2. Oh, come on now. Yeah. which means that A times D over C, we have A times D over C groups of the C over D fit into A. So that might be confusing. So what I do is I look at that the answer 6 is the same as 4 times 3 halves, which is up here. There's 3 halves there. When I take my 1 and divide by the 2/3, that's 4 times the amount as 4 divided by 2/3. So notice that we used to have 1 here, now we have 4 here. And the answer is actually 4 times the amount of my answer here. So there's 3 halves is the answer to number, the first one. And then that's 4, this answer is 6 here, but it's 4 times the amount here. So that's why we have A times D over C is the amount that fits into A. And so that's a good connection there. And part number 4 is when A over B divided by C over D is equal to A over B times D over C. Okay. This is the tricky one. So I'm going to do 4/5 divided by 2/3. So I'm using the same kind of numbers, but they're adjusting slightly each time. So that means how many groups of 2/3 fit into 4/5? So we have 4/5 here. One, two, three, 4. We have 4/5 there. And then we have our 2/3 here. We need to see how many fit in there. Now, as it is written, can we figure that out? And the answer is no, because we don't have the same size pieces. We could fit one of them in there at least. But then how big is that? I don't know. So we need to use a common denominator to help us. I'm going to draw a little bit longer bar, so pieces get a little bit small with this example. Okay, so I'm going to do the 4/5 again. And we know that the common denominator between 5 and 3 is 15. So we'll take my fifths and divide it into 3 parts. All the way down. I'm going to take my thirds and divide those into 5 parts each. You have like parts. This is kind of like a little strategy that you can use to divide fractions. Just find a common denominator in the divide. And I'll show you that in a minute, but right now we're focusing on how many groups of 2/3 fit into 4/5. These correspond right here. The 2/3 ends right here. So that's where my first group of 2/3 is. Okay. We have one group. But this part right here, we need to say, okay, this piece is 2/15. Two-thirds is 10/15, right? We counted those right here, 10/15. So how much of that piece of 2/15, or how much is the 10/15 group size is that 2/15? So the piece is 2/10 of the 10/15, or the 2/3. Which means that the answer is 1 2/10. Okay. I know you can simplify that, but we're going to look at it unsimplified for a minute. Or 12/10. So there's 1 2/10 or 12/10 groups of 2/3 fit into 4/5. Now 12/10 is the same as 4/5 times 3/2. Or it's considered 4/5 of 1 divided by 2/3. Because remember that the answer to 1 divided by 2/3 was my 3/2. Therefore, A over B times D over C. That many groups of the C over D fit into A over B. That's where the confusing part is. I'm still kind of sorting that out. So A over B times D over C, groups of objects. So this is, remember that this is groups of objects. Okay, we can know how that works with multiplication. Here's my groups. And then here's my objects. When you multiply those together, they will cancel here. The red underlined part cancels. And then you have something that is a true statement, like what we've had up here. Okay, so the takeaway from this one is, if you have 1 divided by C over D, and make that equal to 1 times D over C, Then A over B divided by C over D is going to be A over B times the 1 times D over C. Hold on. A over B of the 1 divided by C over D. Okay. Right, so this is the key here. And this copy only notes for just a second there. If 1 over C over D is equal to this, then A divided by B divided by C over D is A over B of 1 divided by C over D. And so we know that 1 divided by C over D is the same as 1 times D over C, which is equal to A over B times 1 times D over C, which is equal to A over B times D over C. So they end up being the same. And because you're taking A over B of my answer here when I divide it by 2/3. All right, so here's our recap. The first step is to show that, I'm going to do this in yellow, 1 divided by a fraction, a unit fraction, gives you that unit fraction reciprocal. Okay. So what I'm telling you now is kind of just the summary, because you're going to be asked on the homework to recap this. So just build it in steps, 4 steps. 1 divided by the unit fraction, okay. Oops. 2, 1 divided by the non-unit fraction, okay, is going to be is D over C, whatever you want to call it, the reciprocal. 1 divided by the unit fraction is 1 over D. So number 3 is you take a whole number divided by the fraction. Okay. And then the 4th step, you take a fraction divided by fraction. Okay, which is what we want to generalize to. So the fraction, again, the fraction divided by fraction is taking your 1 over C over D and doing the fraction part of it. So whatever 1 divided by C over D is, as numbers, you take the fractional part of it. Okay. Now we got to move on to other types of homework problems. I want to finish up in 20 minutes, so here we go. Estimation and fraction division. Somehow I got switched. So what I have on the homework lesson notes is 2 examples of each of these next topics, but I'm only going to do 1 for class because we don't have a lot of time. So look at the lesson notes on Canvas for more of these. So without solving, is 1/3 divided by 4/9 less than 1 or greater than 1? And the key to these problems on homework is to use common denominators. Oops, let me tell you what they're asking though first. What does this mean? Okay. We're going to think about this. If this number is 1, the answer is 1, then that means I can take at least one group of my divisor from my dividend, right? I can take one group of 4/9 from 1/3 if it's 1. So my thinking statement is, can I divide off one full group of 4/9 from my group of 1/3. Okay, so you need to see which one is bigger, okay, to see if you can divide it off. So my recommendation is to use the common denominator. And I'll show you how that works. We're going to take 1/3 and 4/9. Well, 1/3 and 9, so 9 is already good because I can just take my 1/3, multiply it by 3, and 3 there to get 3/9. Okay. So with the common denominator, it's helpful. My new question is, can I divide off one full group of 4/9 from 3/9? What do you guys think? If I have 3/9, can I at least subtract off one group of 4/9 from that?
Yes.
You're starting with 3/9. You can subtract off 4/9 from that without going negative.
Without going negative. So
Right.
if you have the 3, but you have 4, so you have 1 extra, so you can at least get 1 out, right?
Let me think about it the other way. This is my starting number. I start out with 3/9. Can I subtract off 4/9 from that?
No.
No. So that means that the answer is not going to be greater than 1. Okay? The answer is going to be a fraction because I'm only starting with a part of my whole group size. Okay? So if you get stuck on this, you can draw a picture or get the common denominator. Okay. I have 3/9. I want to see if I can take 4/9 from there, and I can't do it. Okay. So I can't take off a whole group of 4/9. And so my answer is going to be less than 1. Okay. If it was 1, if I could take off a full group of whatever, then it would be greater than 1. There'll be some left over. Okay. So there's another example in the lesson notes of that. Similar topic is thinking strategies. Okay. Again, our common denominator is our friend, I think, on this one. Well, you can use it if you want to, but actually these ones aren't too hard. So I have one example here. There's another one inside the lesson notes. If I had 1/4 divided by 1/8, how could we do that one with a thinking strategy without using the algorithm or a picture? What would the answer be? I'm starting with a total of 1/4. I'm taking off groups of 1/8.
1/8 is half the size of 1/4, so you can fit 2.
Excellent. That's your thinking strategy. I'm going to write this out. Since we know that 2 groups of 1/8 fit into 1/4, then 1/4 divided by 1/8 is equal to 2. This is using, I used, which is a good strategy, use the inverse operation of multiplication, the missing factor. Using that form of division. That helped me on this one as a thinking strategy. Because I thought about, okay, 1/8 times something is equal to 1/4. So that something is going to be here. 2 groups of 1/8. Let me go ahead and think about that and switch the numbers a little bit so it makes more sense. We know that there's some amount of groups of 1/8 equal to 1/4. We know that that number is 2. Okay. Since the first number isn't the number of groups in my problem. Okay. Now, they also in the homework, they will have you do just calculations. Okay? So in order to help with the calculations of fraction division problems, you will probably want to simplify before you multiply. Again, there's more examples in the lesson notes, but I'm going to go ahead and just take this, maybe a couple here. 3/5 divided by 11/10. How do I calculate the answer to this?
We have to multiply by the reciprocal.
Okay, what do you think? Let's ask Kenna. Is that right?
I'm sorry, I'm a few steps behind.
Okay. So anybody else? Let's see. Marley, is that right? Am I going too fast? Okay, I need a confirmation from somebody else.
Yes, you multiply by the reciprocal.
Okay, it's a basic question. I just want to see if you guys are on board. Yeah, so that's true. That's how you find the answer to a division problem quickly. We do need to know why the algorithm works, but we're not going to do that kind of deep thinking if we just need to simply calculate a division of fractions problem. We'll just follow the algorithm and just do it. Okay, so that's what these calculations are for. 3/5 times 10/11. All right. Now, what I want to do is with this thinking strategy, I want to make things simpler. Okay. So the thinking strategy says this. Take the 5 and the 10, you cross them out. This is going to be, divide off of 5, that'll be 1. The 10 becomes 5 times 2. And then I can cross out the 5 here. Okay. So I'm taking out 5 from both of them. And that's equal to 6 over 11. Okay. With this crossing out, you guys might have seen this before. I'm crossing out at diagonals. Because usually the fractions that you can simplify up and down as well. Take a look at 3/5, but usually the fractions are simplified all the way before you multiply. But you can look at diagonals and cross them out. So why does this work? This is a shortcut, but you need to know why it works.
Because when you take that, you're really taking a 5 over 5 out of the answer.
Right. Let me make sure I write this a little bit differently. So I'm going to review this here. All right, so I cross those out. Now I'm going to think about factoring this completely. 5 times 1 and 5 times 2. Okay, so the 5 I can factor to 5 times 1. The 10 I can factor to 5 times 2. And that's what I'm really canceling out, these two.
And it only works because you have one on top and one on bottom. If it was like both on bottom, it wouldn't work because you're not doing of one.
Yeah, if you recall, thanks for that. Recall the multiplication algorithm says to multiply the numerators and multiply the denominators. So if you actually do that, you get 30 over 55. Okay. And then you're going to be thinking about, okay, well, what's the factors that are in common between them? Well, 5 does, okay? So 6 times 5 over 11 times 5. And I split off my 5s. And that's going to equal to 6 over 11 times 1, which is 6 over 11. Now, this is the reason why you can simplify from the numerator and denominator, right? You can't cross out the same number from top and bottom if it's just multiplication. Don't try to cross out if there's addition in there or subtraction, because you're writing this as a form of 1, okay? And using the multiplication property identity, okay? Multiplication identity property, you can do that. But why can't I do it at diagonals? Well, when I multiply them together, notice that it still is 3 times 10 over 5 times 11. And again, that was equal to 30 over 35, which was equal to 6 times 5 over 11 times 5. Okay. Now, notice that I'm canceling out the 5s anyway. Okay. So to make it a little bit shorter, let me cancel the 5s out from the beginning instead of doing that again at the end. Because I'm multiplying together, getting big numbers, and then I split them up again. Okay, you can save a lot of time by just canceling before you start. And so places to look are up and down, like this. Usually that's not going to happen because usually they're simplified before you multiply, before you start as you're given the problem. But you can also look at the diagonals, because when the diagonals are, when the two fractions are multiplied, you can still look at top and bottom, the numerator and denominator of the product. Okay. So usually just look for multiplication at the diagonals to simplify there before you multiply. Okay, so there's a couple more on the homework. Or sorry, the lesson notes. The other thing that you'll do with fractions is fraction division with bar models. Now this one is not on the homework, but it will be on the test as a learning outcome. It's just not assessed in the homework. Now what we're doing is we set up the bar models, but we don't solve them in this class. That will be in 2015, so look forward to that. So here's an example. There's another one on the lesson notes. So Joe had a toy car collection. With 24 cars in it. These are 24 cars total. 1/3 of his cars were blue. 1/6 of his cars were yellow. The rest were red. And the question is, how many toy cars were red? Okay. Go ahead and draw a bar. Nice long bar. We know that all of them together is 24 cars. So 1/3 of them are blue. So I'm going to separate out a third here. And I'm going to do blue segment here, my bar. And I can still label it though. Oops. And then 1/6 of them were yellow. So I can take my segment of 1/3 and divide it into two parts here for 1/6, make it yellow. These are the yellow cars. The rest of them were red. So we can just go like this. When you have a bar model, you need to put a question mark for what you're looking for. So these are my red cars. And that's what I'm looking for, so big question mark under there. Okay? And you can deduce what the fraction sizes are by the divisions, but if you want to, you can put a third here and a sixth here. And so on. Okay, so we got that. One more thing, there's another example in the lesson notes. The last one is pedagogical content knowledge. Okay, your PCK. With fraction, our example is fraction multiplication. There's gonna be another couple examples in the lesson notes. Does anybody know what students could do wrong with the fraction, sorry, not fraction division algorithm? Does anybody know what could be wrong?
A lot of the time kids will just write the multiplication and not flip it.
Okay, great. So an example could be like 2/3 divided by 4/5. What will they do? For the example numbers, can you repeat what you said?
So they would do like 2/3 times, and then instead of doing the inverse, they'll just write 4/5.
Okay. All right, we know that that's not equal because we need to find the reciprocal of 4/5, but students might not do that. Another common one is that they'll do the reciprocal of the first fraction. 2/3 divided by 4/5, we said that's equal to 3/2 times 4/5. Okay. So those are a couple of things that students can do. And I have some more examples with the division, but that's kind of all we have for today. We're at time. So let me know if you have any questions on the homework, and you can go through the lesson plans too to get some more ideas. I think that's all I had.
Thank you. Have a good one.
Yep. Thanks, everyone.
Thanks, Dr. B.
Thank you.
You're welcome.
Thank you.
You're welcome.
Thanks.
You're welcome.